Have you ever wondered what the future of moon landings will look like? We all know those iconic images, right? The Apollo lunar module perched delicately on the lunar surface on its spindly legs. For decades, that was the blueprint. But what if I told you the next giant leap for humankind involves a belly flop? It sounds crazy, but SpaceX's Starship is rewriting the rules of space exploration with a maneuver that's as audacious as it is brilliant. This isn't just an update. It's a complete revolution in how we touch down on other worlds. So let's deconstruct this Legless Lunar Gambit. Instead of landing on legs, the Human Landing System, or HLS Starship, is designed to perform a controlled vertical descent and land directly on its skirt, the base of the rocket. Imagine a massive, skyscraper-sized vehicle gently lowering itself onto the moon's surface like a colossal cosmic pillar. The key to this isn't just brute force, it's unparalleled precision. This is where the magic of the Raptor engines and advanced thrust vectoring comes into play. Thrust vectoring is essentially the ability to gimbal, or steer, the rocket's engine nozzles. Think of it like balancing a long pole on your hand. You're constantly making tiny adjustments to keep it upright. Starship does this on a monumental scale. The Raptor engines can angle their thrust with incredible speed and accuracy, allowing the onboard computers to make thousands of micro-corrections per second. This system ensures that even a vehicle of this size can maintain perfect vertical alignment as it descends. It's not just about slowing down, it's about actively flying the ship all the way to the ground, killing every bit of horizontal velocity until it's a pure, straight-down drop. To achieve this, Starship will use a combination of its powerful Raptor engines for the main braking burn from lunar orbit, and then, for the final delicate touchdown, it will switch to a specialized set of high-thrust gaseous thrusters located higher up on the vehicle's body. Why? Because firing the main Raptors too close to the lunar surface would be like hitting it with a celestial sandblaster. The high-pressure exhaust would kick up a massive, high-velocity cloud of lunar regolith. That's the moon's soil and dust. This could damage the engines themselves, sandblast scientific equipment, and create a hazardous cloud that could obscure sensors during the most critical phase of landing. The higher-up thrusters avoid this problem, allowing for a gentle, clean, and safe final approach. It's an elegant solution to a dusty problem. Now let's compare this to the traditional landers we're familiar with, like the Apollo lunar module or even modern designs that still incorporate legs. Traditional landers are masterpieces of lightweight engineering, but their design comes with inherent limitations. First, landing legs add mass and complexity. They have to be strong enough to absorb the impact of landing but also as light as possible to save on fuel. They have to deploy perfectly, and they need to find a relatively flat, stable spot to land, free of large rocks or steep slopes that could cause the lander to tip over. A tipped-over lander on the moon is a mission-ending catastrophe. Starship's legless design elegantly sidesteps these issues. By eliminating the legs, it saves a significant amount of mass. Mass is everything in rocketry. Every kilogram you save on the lander is a kilogram you can dedicate to something else. More fuel, more scientific instruments, or more supplies for astronauts. Starship's wide, flat base also provides a much more stable foundation. It's inherently less likely to tip over compared to a vehicle balancing on 4 narrow points. It can handle slightly more varied and less than perfect terrain, increasing the number of potential landing sites we can explore on the moon. But the biggest game changer is the impact on payload capacity. Because Starship is so massive and its design is so efficient, it can deliver an unprecedented amount of cargo to the lunar surface. We're not talking about a few hundred kilograms of rocks and some experiments anymore. We're talking about delivering entire habitats, large rovers, power generation equipment, and the infrastructure needed to build a permanent, sustainable base. A traditional lander might deliver a small rover. Starship could deliver the garage to put it in. The legless design is a key enabler of this capability. By simplifying the landing structure, SpaceX maximizes the internal volume and mass available for cargo. This direct-to-surface architecture opens up a future we've only dreamed of. Instead of just visiting the moon for a few days, we can start building a lasting presence. Imagine an elevator built into the side of the Starship, lowering astronauts and heavy equipment directly onto the lunar surface. No more climbing down long, awkward ladders. This lunar elevator concept makes accessing the surface incredibly efficient and safe. It turns the lander itself into the first piece of infrastructure at the landing site, a base of operations, a shelter, and a cargo depot all in one. This is how you build a moon base. You don't just land, you arrive. So while the idea of a belly flop on the moon might sound absurd at first, it's actually a stroke of genius born from first principles thinking. It's a design that prioritizes stability, maximizes payload, and simplifies operations. It trades the delicate, complex dance of a legged landing for the robust, confident descent of a self-contained monolith. This isn't just a different way to land on the moon. It's a fundamentally different philosophy for how we will live and work there. The Legless Lunar Gambit is a bold bet, but if it pays off, it will unlock a new era of lunar exploration and settlement, turning science fiction into scientific fact. Thank you so much for joining me on this deep dive into the future of space exploration. If you found this as fascinating as I do, please hit that like button and consider subscribing for more content on the amazing engineering that's taking us to the stars. Let me know in the comments what you think about Starship's landing strategy. Until next time, keep looking up.